Hello dear students, welcome back to the Pharma Learning channel. Today I brought one another new video on the unit operation, and that is the most important unit is present in the field of pharmacy, that is known as a drying. So let's try to understand the details or the introductory part of the drying. So before that, for any of the tutoring or coaching need of any of the subject or any of the topic related to pharmaceutical, pharmaceutical technology, please feel free to contact on the pharmalearning@gmail.com. Also, you can send me the questions that can related to this video or the other videos too. Now, as I told that the drying is a unit operation, the unit operation is a basically process into which it involves only the physical change. So in this case, it is a removal of the moisture. Basically, the unit operation means in this case, the water is going to be removed from whatever the form is that is from the liquid to the vapor. So that's why it is a unit operation. So we are going to remove the water. Okay, generally the water is present in the material, and it is sometimes used as a term like a water content, the moisture content, and the water is present in the air, that is the sometimes the terminology used as a humidity. So we are going to remove more water, that is basically the small amount of the water either from the solid, liquid or the semi-solid by the application of the heat. And what is the final product? Yes, the final product is going to be the dry solid or the powder will be there. Basically, the drying involves both heat and the mass transfer. Let me try to explain you how the both are involved together into this drying operation. So here, in the figure, it is shown like a yellow circles will be, that is like a material atoms will be there, and on the top of that, the hot air, that is the gas, is passing at a particular temperature. It's a high temperature. So as soon as the gas or the hot air comes in contact with the material, it is going to transfer from the hot air to that material atoms itself, and due to which what is going to be happen. So these materials that are shown by this yellow circle, so if any of them the water or the moisture present with this material, which is going to be come out because of the application of the heat, and that material is going to be lost into that environment, or it is coming carried by that gas itself. So here the heat is going to be transferred from that hot air gas to the material, and the water or the moisture is probably going to be lost from that material to the environment or that hot gas. Now, why we are carrying out this drying unit operations? The drying unit operations suppose important to increase the stability of the drug or any of the material, because every drug is more stable into the dry form. We can improve some property of the material like compressibility, flowability, and this is very useful during the manufacturing of the tablet. When we are going for the manufacturing tablet, we are going for the production of the tablet by the products of the granules, and that plays a very important role there. And besides that, if you are going for the any of the drying unit operation, then basically it is useful for the that material after drying. It is easy to handle because it has reduced the weight and it has lost the moisture too. Now, sometimes the students are getting confused between these three terms, such as drying, evaporation, and distillation. So let me clear on this particular slide. Basically, drying is all three are the unit operations. Keep in mind that the similarities will be there. All three are going for the removal of the water or the liquid from the material itself. But here the more important thing is that when the drying is involved, it is going for the removal of the less or the low amount of the moisture will be there, while the evaporation is somewhat carrying out the removal of the large amount of the water, and that into this that water or the liquid is converted to the vapors or the liquid vapors, but we are not collecting them. While the distillation, we are collecting, we are heating that liquid, and we are converting that liquid to the vapors, and we are trying to collect them one. Now, what is the difference? How it is happening at the boiling point? So, drying basically takes place below boiling point. Evaporation, yes, takes place below the boiling point, but yes, distillation takes place at or above the boiling point. Drying is basically done. Now, why? What is the priority? Why we are doing this? All the three in operation. Drying basically is to the stable product, and the final product is a solid nature. Yes, evaporation is done for the concentrating any of the liquid or the reducing the volume of the liquid, while the distillation is done basically for the separation and the purification of the liquid will be there. I can say that drying is a surface phenomenon which basically take place on the surface of the material. Yes, evaporation is again a surface phenomena. It is the materials or that in the case of drying, the water and the liquid which are present in the case of evaporation, the liquid molecules which are present on the top of the surface of the solid in the case of drying, or the top of the surface of liquid in the case of evaporation, they are going to remove first. But in the case of the distillation, okay, the material, the liquid molecules are going to be removed not only from the surface, but it is going to be also removed from the bulk of the liquid too. Yes, now the drying and the evaporation is a comparatively slow process in comparison with the distillation. So I can say that these three are all the similarities, but they are all unit operations. They are used for the removal of the different amount of the water or the liquids will be there. Okay, so that's a similarity. All the remaining differences I just shown into this particular slide will be there. Now let's try to understand certain terminology that is important to related with the drying. The moisture, as I told, amount of the water which is present in the sample, and it can be represented by the amount of the water per amount of the dry substance. The moisture may be of the two types, the bound moisture and bound moisture. Bound moisture means the moisture which is present with the material itself, it cannot be removed. Like say, as for example, the water for crystallization, or it is, let's say, difficult to remove, or it cannot be evaporated easily. While the moisture which can be removed from the material, it is easily, that's called unbound moisture, which is generally present on the surface of the material. So in the case of drying, we are most of the time trying to remove the unbound moisture, the moisture which is present in the surface of the material, with some amount of the moisture which is present with the material. The another term that is called the drying rate. Drying rate means the rate at which the moisture is going to be removed from the material. So it is basically the amount of the moisture which is removed per amount of that particular time. Another term that's called the bond dry substance. Bond dry substance means it is the material which contains either the zero or the no moisture. Ideally or the practically, we cannot find any material which is in the zero or the no moisture, because all the materials are going to remain in the contact with the environment or the atmosphere of the certain terms of the temperature and the humidity. Now let's try to go understand the certain different terminology related with the moisture that may be useful for the further upcoming videos to understand the drying process or the drying unit operations in very detail. The first one, that's called equilibrium moisture content. As the name suggests, that's the amount of the water which is present with any of the material in the equilibrium with the atmosphere. Okay, and that is important. The temperature and the humidity of the atmosphere playing very important role over here. If they are going to changes, yes, the equilibrium moisture content is going to be changes. Uh, Generally for the non-porous materials, as for example talc, basically the talc of the which is used as a lubricant, or the glidant, and which is generally having the equilibrium moisture content that is a zero. Another term that is called the CMC, that is called as a critical moisture content. I can say the critical moisture content is the amount of the moisture that is present once my desired conditions of the drying temperature and the drying time is over. So average moisture content which is present with the constant rate period ends and the falling rate period starts. For this one, or you look at my other the video that is of the drying rate curve to try to understand and go into details for the dry and constant rate and the falling rate period. So it is what I can say, critical moisture content is just present the surface of the material is without. After this one, the material is present without the water, but some of the water is present inside the material. The third one, that's total moisture content. Yeah, it is amount of the moisture which is present in the material before I am going to start my drying process. And the fourth one, that's called the free moisture content. That is the amount of the moisture that can be removed from any of the material. So if I have the total amount of moisture which is present with my material, and what is the unbound moisture, that is the moisture which I have removed. Basically, then if I find the difference between that one, then that will idea will tell that this much amount of the moisture is free, which can be removed at the end of any of the drying process. So for any for look at the more videos for many various topics related to drying and another one, please give like to my video and please subscribe to my pharma learning channel for the more upcoming videos related to pharmacy. Thank you.